These are Advanced Math Notes, Unit 4, Lesson 4. Okay, 4-4 translations. Part 1, vertical shift.
Savingly Kim, please come to the front office. Savingly Kim, please come to the front office.
All right, vertical shifts. We are going to graph number 1, y equals 2 sine of x plus 3. Now this plus 3 is a piece that we've not seen. You may have seen last year, and this could be review, should be review. You've at least seen vertical shifts on other graphs. For sure you saw that last year. All right. We're going to find the amplitude. The amplitude equals 2. The period, you remember from yesterday, is 2 pi over b. This is the b right here. 2 pi over, not x, but the coefficient of x. What's the number in front of the x? It is 1. So it's 2 pi over 1, which is simply 2 pi, just like it used to be. And our vertical shift is how far it's translating up or down. And I'm hoping you remember the plus 3 means it is moving up 3. Okay, so whenever you have these graphs and you're translating up and down, you always do your translation first and then adjust the amplitude second. Again, you translate up or down first and then do your amplitude second. Okay, so I know we're translating up 3. 1, 2, 3. Now, you don't have to do this, but I just draw what I call a fake axis just so I can kind of get an idea of what's going on. This is my fake axis. Now my amplitude is 2, which means I'm going to go up 2 and down 2 from 3. 3 up 2 is 5, and 3 down 2 is 1. That means my graph is going to oscillate between 5 and 1. 5 will be the max. 1 will be the min. What's the length between 5 and 1? 4, and 4 cut in half is 2, and that is what the amplitude definition is. It's the length between your max and min divided by 2, and 4 divided by 2 is 2. All right, so what did we do? We went up 3 first, drew our fake axis, and then set the amplitude as 2, so we went up 2, max is 5, down 2, the min is 1. Okay. Period is 2 pi, just like we're used to. So this is going to be 2 pi. And then we do 2 pi cut in half is pi. Pi cut in half is pi over 2. 1 over 2, 2 over 2, 3 pi over 2, and 4 pi over 2. And it is a sine graph, which means it's the snake shape. It's the one that looks like that, which means it starts at 0, has a maximum, goes back to 0, minimum, back to 0. So here we have what's called fake zeros. I'm going to call them fake zeros because they're not really zeros because I'm on the fake axis. So fake 0, this really is our maximum. Fake 0, minimum, fake 0. Okay, 0 max, 0 min, 0, fake 0 max, fake 0 min, fake 0. So I still have my hill and then the valley. Like so. All right, so you can see the amplitude is still 2. The height there is 2, the length there is 2. The period is 2 pi. And that's it. That's it for this graph. Now, they may ask you on a test or homework or a quiz, where are your zeros? And kids will often say, oh, it happens at 0, at pi, and at 2 pi. And that is false. Those are not your true zeros. Those are your fake zeros. This graph has no zeros because it's always going to oscillate forever and ever. Even on this negative side, it's going to oscillate between 5 and 1, which means it's never, ever going to touch the x-axis. So when they ask you what are your x-intercepts or what are your zeros, there are none. This graph has no x-intercepts. Okay, number 2. Y equals 1 minus cosine of x. Y equals 1 minus cosine of x. Now, you do not have to rewrite it, but I'm going to. And if you're not going, well, I want you to in notes, but on homework, as long as you at least rethink it in your head, this is equivalent to y equals negative cosine of x plus 1. Do you agree? I can flip this around, put the negative cosine x first, and the plus 1 at the end. Again, not necessary, but at least rethink it in your head. Your amplitude is positive 1, because the absolute value of negative 1 is 1. Period is 2 pi over the coefficient here is 1, not over x, over 1, and 2 pi over 1 is 2 pi. And your vertical shift, since it's positive 1, is up 1. Okay, so what is going to happen here? Okay, so remember what I said earlier, you do your vertical shift first and your amp second. So vertical shift is up 1, and that is my fake axis. And then my amplitude is 1, so I'm going to go up 1, which puts me at 2, and down 1, which puts me at 0. Do you see that? So it's going to oscillate between 2 and 0. Okay. The period is 2 pi. 2 pi cut in half is pi. Pi cut in half is pi over 2. 1 over 2, 2 over 2, 3 pi over 2. It is negative. Thinking of what your cosine graph looks like, it's a maximum, a 0, a minimum, a 0, then a maximum. Those are the 5 key points for your cosine graph. And since it's negative, it's going to flip around. So instead of starting at a maximum, I'm going to start at a minimum. So we already said that 2 was the max and 0 was the min. Minimum, fake 0, maximum, fake 0, minimum. So half of a valley, a hill, and half of a valley. All right, so you can see it's just like the cosine graph, but it's been reflected over the x-axis, and it's been translated up 1 unit. So same thing, they're going to ask you what are your zeros or what are your x-intercepts. The wrong answer is pi over 2 and 3 pi over 2. Those are not zeros, those are fake zeros. Your real true zeros, there are some for this graph, is 0 and 2 pi. Those two are your zeros. Okay, so this graph had no zeros. This graph does because it oscillates between 0 and 2 forever and ever. All right. Part 2, horizontal shifts. Okay, part 2, horizontal shift. We're going to rewrite our function like we did in yesterday's notes. Y equals A sine, but I'm going to add more to it. Parentheses, bx plus c, close parentheses, plus d. All right, so this is the whole thing we're going to be dealing with. Now I put sine, but the same is true for cosine. I could change this out with cosine and it's going to be the same type of translations. Okay, as we stated before, A tells us the amplitude, and it's not A, it's the absolute value of A. This tells us our period. Period equals 2 pi over B. Just a heads up, sometimes the B is inside the parentheses like it is here. Sometimes it's factored out to the front. Either it's here or here. It's still going to be right by the X, and that's going to be what's in your denominator to find your period. The C is the new part, so I'm going to hold on to that one. This here is what we had before. This is our vertical shift up and down. This is the part we did in part 1. We went up 3 or up 1 or down 2, whatever your vertical shift is. Now the new piece is the C, and the C is going to be a horizontal shift. How far right and left? Horizontal shift, and you find it by doing bx plus c equals 0 and solving for x. Bx plus c equals 0 and solving for x is going to tell you how far you're translating right or left. And we are going to try some examples and see if we can get it to work. Graph. Number 1, y equals cosine, parentheses, x plus pi, close parentheses. Okay, amplitude is the leading coefficient, absolute value, and absolute value of 1 is 1. Period is 2 pi over b, and both of the numbers either inside or outside, they're both 1, so it's just 2 pi. 2 pi over 1 is 2 pi. Vertical shift is the number out here, and there is no number outside, so I'm just going to put none. Horizontal shift. Now remember, horizontal shift requires a little more work. You take what's inside here and set it equal to 0. X plus pi equals 0. Now I often have kids say, well, it's just the opposite. It's just going to be negative pi. Yes, but sometimes there's like a 2 in front. 2x plus pi equals 0, in which case you'd have to divide the 2. So think it through. When you do this, it does end up being just negative pi because you subtract pi from both sides and you get x equals negative pi. Okay, so this is going to tell you your horizontal shift. If it is negative pi, what does that mean? It means you're moving left pi. Negative means you are moving left a unit in the direction pi units. Okay, now because I'm translating or I'm shifting to the left pi units, that's going to change my start and my end. My start and my end is going to change. Now, prior to this, I always started at 0, and all these other functions, graphs here, I started at 0, and ended at my period. The period was 2 pi, I ended at 2 pi. The period was 2 pi, I ended at 2 pi. And the one from yesterday's lesson, something like this, the period was 4, and we ended at 4, and that's because we always started at 0. Started at 0, ended at pi, because the period is pi. All right, but now that we have this horizontal shift, the start and the end is going to change. Okay, so what's going to happen, your start will always be the horizontal shift. The HS. The start will always be the horizontal shift. So what is the start for us? The negative pi. Okay, the end is always going to be your start plus the period. Your start plus the length of your period. You will need to know this here, so I'm going to bubble it in. You will need to know that. So what is my start? This start is negative pi. So I'm going to put end equals negative pi plus the period. Start plus the period. Here's my start. What is my period? Plus 2 pi. Negative pi plus 2 pi equals positive pi. Do you see how that works? Negative pi, which is my start, plus the period, which is 2 pi. Negative 1 pi plus 2 pi is positive pi. All right, let's see if we can get this graphed. I'm starting at negative pi, and I'm going to positive pi. I am going to scooch these out just a smidge in both directions. Negative pi and positive pi. Now what you want to do is look at the length. What is the length between negative pi and positive pi? The length here, if I go to the right pi and the left pi, the total length between those two numbers is positive pi. If you do the right minus the left, it will tell you the length. 1 pi take away negative 1 pi is positive 2 pi. Let me show you. 1 pi take away negative 1 pi, add the opposite, equals 2 pi. And the length from your start to your end should always be your period. So that is a way to double check. The length from your start to your end should always be your period. Your period is, as I said earlier, how long it takes for you to start and end your graph. Okay, the amplitude is still 1. And the halfway point between negative pi and pi is 0. And then you can add them and cut them in half. Negative pi plus pi is 0. 0 cut in half is 0. 0 plus pi is pi. And pi cut in half is pi over 2. And this is going to be negative pi over 2. And it's going to be cosine, and it's positive cosine, and cosine is the cup shape. So here is my start. It starts at the maximum, goes to a 0, minimum, 0, maximum. That's what cosine does. Half the hill, the valley, and half the hill. And there is our beautiful cosine graph with the translation left pi units. Okay, number 2. Y equals 2 sine parentheses x minus pi over 3. Y equals 2 sine parentheses x minus pi over 3. Okay, amplitude is 2. Absolute value of 2 is 2. Period is 2 pi over 1, because they're both 1, so it's just 2 pi. Vertical shift, there is none, because there's no plus or minus out here. And horizontal shift, we take the inside and make it equal to 0. And you add your pi over 3, and x equals positive pi over 3. So your horizontal shift is pi over 3, positive, which means you're moving to the right. Pi over 3. Okay, start and end. You have to find a start and an end whenever there is a horizontal shift. If there's no horizontal shift, your start will be 0 and your end will be whatever your period is. If there is a horizontal shift, your start and your end change. Remember, the start will always be the horizontal shift, so it is positive pi over 3. And your end will always be your start plus the period. The start is pi over 3 plus the period, which is 2 pi. Common denominator, or 2 plus 1 over 3 is 2 1/3. Multiply and add. All in all, you come up with 7 pi over 3. If you didn't get that, pause it, redo it. Pi over 3 plus 2 pi is 7 pi over 3. Okay. You want to make sure you label your amp, especially if you're not putting tick marks, which you don't have to, especially if the amp is like 10. You don't have to show me all the tick marks. Just label 10 and -10. In this case, 2 and -2. Okay, start at pi over 3 and end at 7 pi over 3. Okay, pi over 3. Now I'm going to lightly count all the way up to 7, but I'm not going to make them too dark because I don't want them to mess up my 5 key points. So there's 1 over 3, and I'm just doing this to keep it spaced out as best I can. 1 over 3, 2 over 3, 3 over 3, 4 over 3, 5 over 3, 6 over 3, and 7 pi over 3. Now I'll darken those in. The reason I don't darken these in, because I should have 5 key points. 1, 2, 3, 4, 5. And right there, there's way too many. So I did them really light just so I could kind of count my way down and making sure that it's as clean as possible. 1, 2, 3, 4, 5, 6, 7. Okay, so when you do this, you get 1 over 3. Oh, okay, sorry. You're going to find your middle by adding and cutting in half. 7 plus 1 is 8. 8 cut in half is 4. So this is 4 pi over 3. And I'm going to put you guys on pause just really quick. Sorry about that. All right, so how did we find this? Again, you add and cut in half. Now, I just kind of did it quick there. 1 plus 7 is 8. 8 cut in half is 4. The real mathematical way is if you do pi over 3 plus 7 pi over 3 cut in half. And you're going to see it works out much easier the way I said it. 1 over 3 plus 7 over 3 is 8 pi over 3. Divide by 2 is the same as times 1/2 because I multiply by the reciprocal. 2 is 1, 8 is 4, 4 pi over 3. So there's the real math way. You add and cut in half. And that's always how you find the midpoint. When you're looking for midpoint, you take your start and your end, add them and cut them in half. Start and end, add and cut in half. And when we do all the math, it's the same as just adding the numerators and cutting it in half. 1 plus 7 is 8. 8 cut in half is 4. Denominator stays the same. Now that only works if the denominators are already the same. All right, I'm going to erase those ones that I said I'd do lightly because I'm not going to need them. But I'm going to put the middle there and the middle there. And I'm going to end up with decimals within fractions, which I do not mind if you use. If it bothers you, I'll show you other ways of doing it. Okay, 4 plus 1 is 5. 5 cut in half is 2.5. So 2.5 pi over 3. 4 plus 7 is 11. 11 cut in half is 5.5 pi over 3. If that really bothers you, then do what, like for example right here, 1 over 3 plus 4 over 3 is 5 over 3. 5 pi over 3 cut in half is 5 pi over 6. 2.5 pi over 3 is equivalent to 5 pi over 6. If you don't like the decimals within fractions, do it this way. I'm going to continue doing it this way for this problem. All right, it is the sine graph, and the sine graph is the snake shape, which means it starts at 0, and then it goes up and down and back around, and it has an amplitude of 2. So this is my start, 0. My next key point is a maximum, 0, minimum, 0. Hill, and then a valley. And there is your beautiful sine graph. Now, as I stated earlier, your period should always be your end minus your start. 7 pi over 3, take away 1 pi over 3 is 6 pi over 3, which is 2 pi. And that is your period length. If you do your end minus your start as your double checker, it should always be your period length. Okay, number 3, y equals -4 plus 5 cosine pi over 12 x. So remember what I had stated earlier about at least rethinking it. I'm just going to rewrite it. The cosine piece first, 5 cosine pi over 12x, and then minus the 4. And this here is what I'm going to graph. Amplitude is 5. Period is 2 pi over 12, multiply by the reciprocal. You multiply by 12 over pi, and the pi's reduced. It ends up being 24. Vertical shift is down 4 because it's negative. -4, that means it's down 4. And horizontal shift, there is nothing in the parentheses here. Do you see that? That means there is no horizontal shift, so I'm going to write none. Okay, I am going to have you guys graph this, and when you come into class tomorrow, you're going to show it to me. So this is going to be your proof of notes. Well, all of the notes plus this one done. So when you come into class tomorrow, have this out, have this open, because I will be walking around checking your number 3. Doing the best you can. Even if it's wrong, at least you tried, and then we will do it together and check. So go ahead and finish it off and bring it into class tomorrow.